Okay, question number 3 is from simple harmonic motion. A pendulum made of a uniform wire of cross-sectional area A has time period T. When an additional mass m is added to its bob, it means earlier there was a certain mass of bob, so that may not be required, so that's immaterial. So additional mass capital M is added to its bob, the time period changes to T sub m. That's a new value of time period. Young's modulus of material is given as y, and we need to calculate 1 by y. So let's say in the beginning, this is the situation, and there is a certain mass which is not given, so that's immaterial. Let L be the total length at the initial stage. So that L would also include the original length and the extension. So L is the resultant consolidated length. And with this, the time period is 2 pi root L by G. At the second instance, what has been done is an additional mass has been kept. So whatever was the mass plus m is there. Of course, when you add additional mass, this would also result into extra elongation of the wire. So let that extra elongation of the wire be delta L. So now the new time period would be given by 2 pi under root L plus delta L by G. And regarding the calculation of value of delta L, one can always use the concept of Y, which is stress, that's mg by A upon strain, delta L by L. So that delta L is the extra elongation due to this mass that has been written in capital K. So let me put it here. So we have this equation, this equation, this equation is a very easy solution, and from this you can calculate the value of 1 by y, and that will lead us to option number 3. So now let's proceed to question number 4. Question number 4 is again pertaining to simple harmonic motion, and this time we got to choose the correct variation of kinetic energy represented by Ke, potential energy Pe with respect to displacement. So let's see, the kinetic energy comes out to be 1/2 mv square, and that would be omega square A square minus d square, because this time the displacement is represented by d. And potential energy is 1/2 m omega square d square. This is of course taking reference as the mean, which we do when specifically a mean position is not specified. Now the variation of kinetic energy with d is parabolic in both the case. This would be an upward parabola, this would be a downward parabola, and that correctly represents option number 4. Now let's move on to question number 5. Question number 5 is from the topic sound wave, and it has been set from Doppler's effect. A train is moving on a straight track with speed this much. It is blowing its whistle at frequency 1000 Hz. The percentage change in frequency heard by a person standing near the track as train passes him is. It means if this is the train and the person is standing here, initially as the train approaches there is one frequency heard, and that f1 would be f. If I represent c by speed of sound, so that would be c upon c minus vt, where v sub t is the speed of train. That is the first frequency heard when the train is approaching. In the second case, the person is here and the train recedes, and in that case the frequency heard is f c by C plus Vt because the source is moving away. So here I have F1 and F2, and if I need the percentage change, so of course that would be F1 minus of F2 by F1. I'm talking of the magnitude of percentage change multiplied by 100%. Plugging all those value, you would land to option number 4. So now let's move to question number 6.